Thought I'd do a quick quantum check-in so that you know I haven't given up on the search for quantum mechanics. We're at that point where I always get a little bit hung up, and that is the ultraviolet catastrophe. So we know the solution that Max Planck came up with. His solution was that energy comes in packets rather than a continuous spectrum of energy. How he arrived at that is a little complicated. I have this book by Max Jammer, which basically goes through the way mathematically and in terms of experimentally that Planck and others got to where they got. And one of the things that Jammer says is that it's unfortunate that Planck came to his conclusion by such a difficult route. What I mean by that is that the experimental situation and theoretical situation that led Planck to his conclusion involves pretty deep thermodynamic kinds of considerations. So I don't have it completely mastered, so I'm just going to do a little. I'm still working on it. Video this week, and let me talk about the ultraviolet catastrophe as it was called. So, thermodynamics really developed extensively in the 1800s, and there was the birth of something called statistical mechanics. And statistical mechanics is basically you can't track every individual atom in a gas, for example. Let's say you've got a balloon full of air molecules. There's oxygen in there. There's traces of other gases in there, and you can't track every oxygen molecule. There's just too many of them. And so there was the rise of what's called statistical mechanics. And statistical mechanics basically says what is the average, for example, energy of each particle. We don't know the specific, but we can kind of average it out. And there was a theorem that developed called the equipartition theorem. And it's the idea that the energy in a balloon, in the molecules, is basically evenly distributed. The energy gets evenly distributed among all the different molecules and gas atoms in a particular volume. Now, for whatever reason, and there was a reason. This is the part where I haven't fully grasped it. There was a reason why some thermodynamicians, that's not a word, but for example, Rayleigh-Jeans, there's a Rayleigh-Jeans formula for this sort of thing. And the early versions of this formula basically assumed that energy would be distributed equally across all frequencies. Now, the problem is that if the energy is distributed among all frequencies, the correlation between frequency and energy is such that as it got distributed to higher and higher frequencies, the energy would be greater and greater. And basically, and of course, they were especially exploring something called black body radiation. A black body is a theoretical cavity where basically none of the energy escapes. It all gets captured in that black body. It absorbs all frequencies. And given the math at the time, in the late 1800s, basically the energy would have distributed to all the frequencies, and you would have such high energy that basically it would fry us all. Simplification. I asked ChatGPT. It said, "Okay, that's a little crude, but you're kind of expressing the situation." Again, I apologize that I don't fully have a grasp of what it was, but in a way, we don't really have to know. Basically, Planck's solution to this catastrophe was to say that the energy doesn't equally distribute among all frequencies. That in fact, the higher you go, the more energy it takes for it to be distributed even further. Or maybe you might think of it as water that overflows, that the water doesn't overflow to the higher frequency until it's full. And so it takes more and more water to overflow the farther you get. This is a very crude analogy that I'm giving. And so Planck basically concluded that it took a discrete packet, that energy came in discrete packets, and that it took more and more energy to go to the higher levels. And so you never had the ultraviolet catastrophe. And this is very crude, and I'm hoping that one day I will watch this video and think, man, you really didn't fully understand what was going on, did you, Ken? But this has been my attempt to put a pulse through the quantum mechanics journey that I'm on. Have a great day.